Hello and welcome to our lecture on chemistry, and we'll also talk about water chemistry. This first lecture video is just going to be a basic introduction to chemistry. So what makes up our world? Matter is the term used to define anything that occupies space and has mass, which is a measure of the amount of material in an object. So what makes up matter is chemical elements, or are chemical elements. Okay, so for example, like let's say I have a rock that is made up of salt, right? You've probably seen those like salt lamps, or maybe you've seen an actual, like you have a rock of salt. Okay, so that is going to be matter, right? And that's going to be made up of elements. So an element is a substance that cannot be broken down to other substances by chemical reactions. And what I'm showing you here is the periodic table of elements. So these are the elements that we know of, and there are 98 elements in nature, but only a few exist in a pure state, meaning that they are not bound to something else. Okay, so back to my salt rock. Okay, my salt rock is made up of two elements, sodium and chlorine. So sodium is right here. Its chemical symbol is Na, and chlorine is over here. Its chemical symbol is Cl. Okay, so my rock, which is matter, is made up of elements, sodium and chloride. Okay, so an element can't be broken down by chemical reactions. Okay, so let's say, we have some wood, right? That would be matter, and it's made up of multiple elements. When we burn it, it turns into ash, which is carbon. The rest of what is making up that wood is basically put into the atmosphere as gas. So we have it burnt down to one element, which is carbon in the ash. If you burn the ash, it's still ash. Nothing changes because you've taken it down to the basic element. Now, the human body is made up of elements as well. So the majority of the human body is made up of oxygen. So that's about 65% of the body. Then you have carbon, then you have hydrogen, then you have nitrogen. And I often refer to this as CHON, although that's not, I guess, the correct order as far as the percentage goes. But carbon, hydrogen, oxygen, and nitrogen make up the majority of the elements in your body. Okay, but that doesn't mean that you don't have small amounts of other elements as well that make up your body. And we will learn, I believe next week, that the body is not just made up of elements, it's actually made up of compounds. So we'll talk about that in a little bit. So we've got all these different elements that make up matter. And then if we look at an element, that makes up the element. So each element consists of one kind of atom. An atom is the smallest unit of matter that still retains the properties of an element. So each atom consists of three subatomic particles. We have protons, electrons, and neutrons. Protons are positively charged, electrons are negatively charged, and neutrons are electrically neutral. So here we have an atom of oxygen. So it's made up of protons and neutrons and electrons. So this is a single atom of oxygen. Now, what does an atom actually look like? Well, what we have is what's called the nucleus of the atom, and that's made up of protons and neutrons. That's at the very center of the atom. And then on the outside, orbiting this nucleus, are the negatively charged electrons. So electrons orbit the nucleus. And if we were going to compare these subatomic particles, the protons and neutrons are much larger than the electrons. So let's say that a proton is equal to a bowling ball as far as its mass goes, then an electron would be equal to a lifesaver, like, the little candy, right? It's a lot lighter than a proton is. Okay, and as far as like the size of the nucleus compared to the size of the electron cloud, which is basically the orbiting electrons, everything that makes up the atom that is outside of the nucleus. If we were to compare that, so here we have San Francisco Giants ballpark, which gets names changed all the time. But what we would have is, say that this ballpark is an atom. The nucleus would be like a fly in center field, and the electrons would be like a gnat orbiting out around the stadium. Okay, so you can see that the nucleus is pretty small as compared to the electron cloud that is orbiting around it. Okay, so let's look at an example of what we see when we look at a periodic table. Okay, so here we have an H, and that tells us it's hydrogen. Some periodic tables only show us this H and don't actually tell us what the name is. The H is the element symbol, and so every element has its own symbol, and hydrogen is the element name. Like I said, lots of periodic tables don't even say hydrogen, they just have an H. This number over here in the upper left corner is called the atomic number. The atomic number equals the number of protons a single atom of that element contains. So a single atom of hydrogen only contains one proton. Then down here, this is called the mass number. It is the number of protons plus the number of neutrons. Okay. Now, when we look at a periodic table, we can figure out the number of protons, right? And we can also figure out like how heavy the nucleus is, or how much mass it has, I should say. But what subatomic particle is missing from this? We should say electrons. Now, there are a couple of different reasons why this might be the case. One, you can assume that the number of protons is equal to the number of electrons. So, hydrogen would have one electron because it has one proton. But also, when one atom bonds with another atom, they can tend to donate electrons or share electrons. So the number of electrons that a single atom has could change depending on if it is bonded to another atom, okay? And I would also like to note that some elements can exist in different forms that are called isotopes. So these have the same number of protons and electrons, but different number of neutrons. Therefore, isotopes of the same element will have different mass numbers, okay, because of the difference in the number of neutrons. But it would still be the same element, okay? So each element has a specific number of protons, okay, and that's why, like, that's basically what is defining that as that specific element, okay? So we looked at hydrogen, which has the 1, right? So that means it has 1 protons, and I want you to look at the periodic table and tell me how many protons, say, carbon has. Carbon is, the element symbol is C. Okay, so it's right here, carbon, and you can see a 6 here. So that means that one atom of carbon has 6 protons, and you could also assume that it has 6 electrons as well. Okay, so I sort of mentioned this already, but what happens when multiple atoms join together? We have bonds that are created. Okay, so We have molecules, ions, and compounds that are formed when you have multiple atoms that are bonded together. A molecule is electrically neutral, a group of two or more atoms held together by a chemical bond. Okay, an ion is an electrically charged atom or a group of atoms held together by a chemical bond resulting in a net positive or net negative charge. Okay, so ions are charged, right? So if you think of things being conductive, they're conductive because of the ions, because you can have a current running from one electron to the next because of the charge. Okay, so for example, pure water, just pure water is not charged at all, right? And you might be surprised to hear that because you're like, well, I'm not supposed to take a bath and have, electronics around me because I could electrocute myself, but I shouldn't be able to electrocute myself in pure water then. The thing is that it is the stuff that gets dissolved in the water that makes it conductive and could make you get electrocuted. So even if you filled up your bathtub with perfectly pure water, like tap water is not pure water, so you would need like deionized water or something like that. You need perfectly pure water. And then you got in the bathtub, well, you've got particles on your skin that will dissolve into the water and make it conductive. So you could never take a bath in totally non-conductive water. Okay, so again, don't take a bath with electronic equipment around. Okay, so an example of an ion is shown here, and this was what I was referencing earlier, which is salt, sodium chloride, NaCl. Okay, and over here is an example of a molecule. This is a water molecule. So molecules and compounds are held together by attractive forces between atoms. Those attractive forces make those atoms bond together. There are a couple of different types of chemical bonds. Okay, so attraction between atoms bonds them together. So let's look at the different types of chemical bonds. A covalent bond is when each atom in a molecule retains its electrons but shares them with adjacent atoms. An ionic bond is when one atom gives up one or more electrons, which is captured by another atom. Okay, and ionic bonds, because one atom is giving up an electron, that's going to make it positively charged, right? That's going to make that atom positively charged, and then the atom that gains the electron is going to become negatively charged. Okay, so that makes atoms electrically charged, and we call those ions. And then the third type of bond is a hydrogen bond, and that is a bond that forms between hydrogen and a negatively charged atom, and that hydrogen is already attached to another atom. Okay, so you have an atom that is attached to hydrogen. That hydrogen ends up being positively charged because it's so small that the other atom tends to pull its electron away from it, and therefore that makes it positively charged, and it can attach to a negatively charged atom in that way. And we'll talk more about this because that is how water molecules attach to each other, is by way of hydrogen bonds. Okay, so let's look at these three bonds and a little with examples. Okay, so a covalent bond, again, is where you have atoms that are sharing electrons. So here we have nitrogen gas. Okay, so nitrogen gas, here's nitrogen gas is N2. Okay, so we have one atom of nitrogen here. We've got, sorry, I didn't want to show you that yet. We have another atom of nitrogen right here, okay, and they have 7 protons. That 7 is nitrogen's atomic number. And when those come together, they share electrons. And we can see these are the electrons that are getting shared. There are 1, 2, 3, 4, 5, 6. That means that each atom is sharing 3 of its electrons with the adjacent atom. And so we can write that by saying N with 3 lines and then another N. That is saying that they are each sharing 3 of their electrons with each other. So you could say that that is a triple bond. And about 78% of our air is actually made up of nitrogen gas. Okay. The second type of bond that we discussed is the ionic bond. So again, with an ionic bond, you have electrons that are being donated from one atom to another, and that creates ions, which are positively or negatively charged. Okay, so here we have sodium, which the element symbol is Na, and over here we have chlorine, which its element symbol again is Cl. Okay, so sodium ends up donating an electron to chlorine, and that then makes sodium positively charged and chlorine negatively charged, and this bonds them together. Okay, so we have sodium chloride, which is written NaCl, and again, now we say instead of just Na in this little atom here, there's a little plus sign next to it, and instead of just Cl, there's a little negative sign. The plus means that this atom of sodium is positively charged, and this negative next to the Cl means that this atom of chlorine is negatively charged. Okay, so we have a positively charged atom here and negatively charged atom here, and what do we call charged atoms? We call them ions. Okay, so again, the reason why sodium is positively charged is because it has one fewer electrons than it does protons now because it donated it. So it has one more proton than it does electrons. That makes it positively charged. The chlorine is now negatively charged because it has one more electron than it does protons. So that makes it negatively charged. Okay, and then finally our hydrogen bond. So hydrogen is where you have, or hydrogen bond is where you have a hydrogen that is bonded to something else already. It's going to be bonded to like oxygen or nitrogen as an example. And that makes the H side of that molecule positively charged. So because the H is positively charged, anything that is negatively charged, so any kind of ion that is negatively charged can attach to it. And that's going to attach to that whole molecule. Okay, these are relatively easily made and easily broken in comparison to covalent bonds or ionic bonds. That doesn't mean that they are easily broken, as we'll talk about when we're looking at the thermal properties of water actually. And a couple of other properties as well. Those hydrogen bonds are actually quite strong when we think about it. Okay, so these form between water molecules, for example. So here we have one single water molecule, okay, and one single water molecule is made up of two hydrogen atoms and one oxygen atom, and the oxygen and the hydrogen are bonded together by way of a covalent bond. So the hydrogen is sharing its electron with the oxygen, and this hydrogen is also sharing the electron. Okay, so this makes it, because look how big this oxygen is, it kind of hogs the electrons, and so the end that has the hydrogen ends up being positively charged. Because of that, it can attach to other negatively charged molecules or atoms. So because the H is positively charged, the oxygen's hogging the electrons, it makes that side negatively charged. So now we have another water molecule that can bond to this one by way of a hydrogen bond. And then we have another one that comes along, and it could also bond to this one by way of a hydrogen bond. Okay, so that leads us to start discussing water. So water is a pretty amazing substance. It is the most common substance on Earth. It has the ability to store huge amounts of heat, and it can dissolve almost anything. And its properties allow it to have life exist underwater and also exist underwater even when the surface of the water is frozen, because the properties of the water make it so that the water doesn't freeze from the surface all the way to the bottom. It only freezes at the surface. Okay, and these properties are this wondrous water is due to its chemical and physical properties, which we're going to discuss in the next lecture video. Okay, so I want you to take a little break before you move on to the next video, and think about what is water. I want you to just jot down everything you can think of to describe water before you go on to the next video. And no, you don't need to turn this in. It's just something for you to think about. Okay? Thanks, and have a good day or night.